Okay, so today is sort of a culminating day of our work with triangles. We're going to do 2 days on this at least. We'll see how it goes. But today what we're going to look at is we're going to look at our triangle decision tree. So any one piece of what we've done with triangles so far, with sine law, cosine law, Pythagorean theorem, SOHCAHTOA, any one of those pieces isn't terribly challenging. Like, it's not an overwhelmingly complex idea. The real problem comes in when I just lob a general any old triangle at you and say, go ahead and solve that. And then knowing what to use when is what really causes a lot of students some issues. So this is going to be a triangle decision tree that lets us decide, what pathway to follow when. So it's going to be posed as a tree. It's going to be a series of questions that we decide, and depending on what the answer is, we're going to follow that particular branch. So before we even get into decision making, the very first step that I would always want you to do is, so step one is, if we know two angles in the triangle, solve for the third. Now, this is not always an actual requirement, but it definitely saves our bacon in some cases. So the very first thing we should do, if we know two angles in the triangle, solve for the third. Okay, so we should always do that. And here's where we actually start asking some questions. So the next little step here is we ask the question, is this a right triangle? Okay, so we ask ourselves, is this a right triangle? Does it have a 90-degree angle in it? And of course, there's one of two answers. There is either an answer that is yes, or potentially that there is no, or maybe we don't know. Okay, and if we don't know, we have to assume that it's not. Okay, so if it's yes or no, or we don't know. So those are our two possible outcomes. So here we go. If it is yes, what tools do we have at our disposal? Well, if it's a yes, we know that we can use Pythagorean theorem is available. Okay, and we would use Pythagorean theorem if we know two sides. And want a third side. So one choice, is Pythagorean theorem if we know two sides and we want a third side. Otherwise, we're going to be relegated to our primary trig ratios. And that is, of course, SOHCAHTOA. Now, I'm not going to put the cookbook recipe of how to use SOHCAHTOA in here. We've done that before. You can look back in your notes or theoretically to my other video on that. But, if we ask the question, is this a right triangle? Yes. Well, that means we can use Pythagorean theorem or we can use primary trig ratios. Okay, so that's not bad. We should be fairly proficient with that by now. Now, on we go. If the answer to is this a right triangle is no, or we don't know, we have some more questions to ask. Okay, so the next question we're going to ask is, do we have a known angle opposite a known side? Okay, so what I mean by that is, after we've got all of our labeling done and we've found if there was an unknown angle, if there were two angles and we could solve for the third, when we go ahead and we solve, so imagine that we knew that this was 8 and this was 7, and imagine that we knew this angle up here. Imagine that this was 60 degrees. Okay, if this is 60 degrees, we're asking, do we have a known angle opposite a known side? Well, here's the only angle and here's the side. So I draw this loop like this, and we don't have the known angle in there. So this one would have an answer of no. Whereas if we had a different triangle, imagine that we had that this was 35, no, it's going to be 45 degrees, and this looks to be more like 50 degrees. And we knew that this side was 6, and we were looking for this x over here. Well, in this case, we have a known angle. So here's a known angle opposite a known side. So that would answer a yes to that. Okay, so do we have a known angle opposite a known side? So again, this is a binary decision. This side is going to be for yes, and we're going to go down here if we have a no. If it is a yes, if we have a known angle opposite a known side like we do right here, this means that we are going to use sine law. Okay, so that's going to be sine law. And if we don't have a known angle opposite a known side, then that, of course, relegates us. The last choice we have at our disposal is cosine law. Now, we can do some generalizations. When it comes to naming triangles, some textbooks or some videos, if you watch other videos, we'll talk about an angle side angle or a side side angle or an angle angle side or a side 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 triangle. And I'm going to kind of do a quick summary of that here so that we can use or we can decide based on that as well. So sine law is useful to us if we have a known angle opposite a known side. So I'm going to draw out a couple of different cases of what those look like, and we can watch for those cases as well, and that will help us decide as well whether we need to use sine law. But really it comes down to, do we have a known angle opposite a known side? So sometimes some triangles are called, or imagine we had the following triangle. Imagine that we had that this was, this is 10 meters, this is 9 meters, and this angle in here is 24 degrees. This triangle, we would be good to go on sine law, of course, because we have a known angle opposite a known side. If we draw a little loopy like this, the little loopy contains a value at both sides. So we're good to go. This is commonly known as a side-side angle triangle, because if you list off the things in order of what we know them, so we know a side, we know a side, and then we know an angle. So this is a side-side angle triangle. So triangles that are of the form side-side angle or angle side-side are good to go. We can use those in sine law. Alternatively, if we, I don't remember what color that was, something like this. If we knew that this was, I don't know, this one looks to be 30 degrees and this one was 50 degrees, no more than that, 60 degrees, whatever, doesn't matter. And we knew that this side over here was 8. If we list them in order of what we know things, we know an angle, and then the next thing we know is another angle, and then we know a side. So this one would be an angle side triangle. Okay. So, or if we went the other direction, or if we do this side down here, it would be a side angle. Same as this one. You guys can all giggle and titter if you want. This is angle side. Okay. So if we have a side angle or an angle side triangle, angle side angle, those are all good to go with sine law. But I find it's just much easier to consider, do we have a known angle opposite a known side? And as long as we have a known angle opposite a known side, we're good to go with sine law. Okay. Whereas cosine law is kind of, it's our not our last resort per se, but it's the last choice that we fall into. So if I draw off the couple of different versions, there's really only 2 versions that we can use the cosine law effectively for. Those aren't the straightest sides ever, but anyways, here we go. So cosine law, if we know that this is 15 meters, this is 13 meters, and this is, I don't know, 38 degrees, this is known, sometimes people call it an angle sandwich because it's in between 2 sides. We have an angle in between 2 sides. So if we use this kind of naming convention that we've used over here, this would be known as a side angle side, because we have a known side followed by a known angle followed by a known side. And so with a side angle side triangle, we can solve for this x over here. Okay. The reason we couldn't use sine law, this is our only known angle, and over here we don't have a known side. So we couldn't use sine law, but we can use cosine law. Side, angle, side. Okay? So an angle sandwich lets us solve for the opposite side length, and that's how cosine law could be used. Okay? And then the other potential method for using cosine law is we could do, if this was a 5, this was a 7, and this was an 8, and I wanted to solve for this angle right here. Well, first off, why couldn't we use sine law? Well, we couldn't use sine law because we don't even have any known angles. So we definitely couldn't use sine law. So this triangle, as you could probably guess, is going to be known as a side, side, side triangle. And side, side, side triangles, we can use cosine law. In fact, we can only use cosine law in that case to solve for the unknown angle. So that is our triangle decision tree. So really briefly again, if we know two angles, solve for the third. Okay. Is this a right triangle? Yes or no? If yes, we've got Pythagorean theorem, we've got primary trig ratios. If no, do we have a known angle opposite a known side? If yes, sine law. If no, cosine law. So that's our triangle decision tree. So I'm going to do a couple of examples with you here where we're going to walk through this. So we'll start out with, the following triangle. So let's look at some examples. So example A, imagine we had the following triangle. So draw it a decent size. Imagine that we had, this was, I don't know, this looks to be 60, get back here. There we go. 64 degrees, and this angle looks to be a bit bigger than that. Imagine that this is 70 degrees. And I know that this is side length 15 meters. And what I want to know is this one right here, x. So if we actually venture into this and we think about what's going on, well, what we've got going is we look at our triangle decision tree. Now, first rule in the triangle decision tree says if you know two angles, solve for the third. So I'm going to do that. So I know that the three angles inside of a triangle have to add up to 180. So I'm going to grab my calculator and I'm going to say 180 minus 64 minus 70 to find out our unknown angle. So here's our unknown angle. It's 46 degrees. So I go back here and I say, all right, this is 46 degrees. Okay, so that's the first step. If we know two angles, solve for the third. Done. Next, we have to start asking our questions. First question is, do we have a known angle? Or sorry, first question is it a right triangle? Well, none of those are 90 degrees. So no Pythagorean theorem, no SOHCAHTOA. Next question, do we have a known angle opposite a known side? In fact, we do, because we've got that known side opposite that known angle. Now look, I did this example on purpose. Had we not found the third angle when we knew two, we wouldn't have had that, and we wouldn't have gotten anywhere near to where we needed to get to. Okay, so it's really important if you know two angles to solve for the third. Lovely. So we have a known angle opposite a known side. That means we have to use sine law. Now, cast our mind back to sine law. We've done that over the last couple of days. With sine law, I know that it's A over sine A equals B over sine B equals C over sine C, or upside down. And the way we decide which version is most relevant to us is we want to put what we are looking for in the numerator. Well, we are looking for a side length. So this is the version that we want. So we have A over sine A equals B over sine B equals C over the sine of C. So we're going to substitute all those in. Well, you can label off your vertices. You're welcome to do that. But really, it's just really important that we have the appropriate sides matching up. So I've got 15 over 46. So 15 is the side length that matches up to the sine of 46 is equal to, in this case, it's going to be x over the sine of B. So that's going to be 64 degrees. So over the sine of 64 degrees equals C. Well, I guess this one would be C down here. We don't actually have it, so I'm just going to leave it as C over the sine of 70 degrees. okay? So think back to sine law. What do we have to have? Well, we need one complete ratio. Well, luckily, there is a complete ratio. And if you think about how we get into this case, this is how we know sine law is going to work for us. Because if we have a known angle opposite a known side, right? Known angle over known side, it means that we're always going to have a complete ratio because we have an angle and a matching side, right? So that's how we make sine law work, is we have to look for, basically what we're looking for when we have a known angle opposite a known side, is we're looking for a complete ratio, which we've got, okay? And then we have to have a half complete ratio. Well, in fact, we've got two half complete ratios. So we could use sine law to solve for both of those sides, but we really only want x for this particular example. So there it is right there. So I'm going to take it, I'm going to rewrite those. So we can have 15 over the sine of 46 is equal to x over the sine of 64. I'm going to multiply both sides by the sine of 64, multiply by the sine of 64. These guys are going to divide out to become 1. They're going to kind of cancel each other out. And then we're going to have that x is equal to the result of that expression. So I'm going to grab my calculator. And we're going to do the sine of 64 times, I have to close that bracket, times 15 divided by the sine of 46. And when I do that, I find that the unknown side length there is going to be 18.74 meters. So 18.74 meters is our unknown side length. Lovely. Okay. So let's try another example. There was example A. Let's go with example B here. So example B. Imagine that we had the following triangle. Okay, so sometimes it does that. There we go. All right, so imagine that this was 8, this was 9, and this was 5, and those are all going to be in meters, meters, meters. And what we want to find is, I don't know, how about this angle down here, x, okay? So let's go through our triangle decision tree again. So the first thing we do is, if we know two angles, we have to solve for the third. But we don't know any angles, so we can't do that. And then we ask ourselves a question, is this a right triangle? I don't know, it's a good question. It might be, but I don't know that it is. So if we don't know that it is, we can't use Pythagorean theorem and we can't use SOHCAHTOA. So I'm going to have to go with one of the alternatives. And we think, all right, next question we ask, do we have a known angle opposite a known side? Well, here's the angle I'm interested in. I don't know any other angles. So I don't have a known angle, so I can't use sine law. That means that I know, hey, this is going to have to be a cosine law problem, right? So if it's cosine law, then we're going to go through our cosine law cookbook. So cosine law says C goes on the angle we know or we want to know. Ooh, there's the angle I want to know. And it's going to be uppercase because remember, they always get labeled uppercase. And then we can label off our sides A, B, and C. Well, there's lowercase c, lowercase a, lowercase b. Now I'm going to write cosine law out. C squared equals A squared plus B squared minus 2AB cosine of uppercase C. Fill in the values. Well, lowercase c is 5. Lowercase a is 9. Lowercase b is 8. So minus 2 times 9 times 8 times the cosine of, well, here's what I'm looking for, cosine of x. All right, time to solve. So we can simplify each of these expressions. So we're going to have 25 is equal to 81 plus 64 minus 72 times 2 is 144. So minus 144 cosine of x. Okay. Now, this is a constant, this is a constant. I can't just put all these together because this cosine of x is multiplying the 144. There's the common mistake kids make, is they try and take and simplify all three of those things, but we can't do that. Lob the 81 over, lob the 64 over. We're going to get 25 minus 81 minus 64 equals negative 144 cosine of x. Okay. Divide both sides by negative 144. Divide by negative 144. Those guys are going to go away. we're going to get the cosine of x is equal to, so I'm going to take and simplify that numerator right there. So we're going to have an address violation, lovely. Okay, so we're going to have 25, not 0.25, 25 minus 81 minus 64. So the numerator is negative 120. So I'm going to come back here and say, all right, this is negative 120 over negative 144. I want to get the x all by itself. Right now, cosine is working on the x, so we're going to have that x is equal to the cos inverse of negative 120 over negative 144. Get rid of those, and we're going to have that x equals, okay, so second function, cos inverse of negative 120 divided by negative 144. Close that off. And we're going to get that is 33.56. So we just found that that angle was 33.56 degrees. There we go. Okay, so there are a couple of different things that we have going on. That's good. So tomorrow what we will do is we will do much more practice with this. We'll look at a bunch more examples, and we'll look at not just solving for one thing. Tomorrow we'll look at solving triangles, which means to get all of the unknown values for the triangle. Okay, thanks. See you tomorrow.